Okay, so in this video we're going to talk about average rate of change. So let's first define the average rate of change. So the definition of the average rate of change so the average rate of change of a function f of x from x equals a to x equals b is the following quotient: f of b minus f of a all over b minus a. And graphically what the average rate of change is it's the slope of the secant line. Slope of the secant line through the points a f of a and b f of b. Let's draw a picture here. So we have some function. We have a point A and its output f of a, and we have a point B and its output f of b. So if we draw a secant line through those 2 points, the rise is going to be f of b minus f of a, the rise from a to b, and the run is going to be b minus a. So the slope is f of b minus f of a over b minus a. All right, so let's do an example where we compute this average rate of change. Call this example 1. So suppose we have a function and the function is measuring the height of a ball over time. So here's the function. It's 100 minus 16t squared. The outputs are in feet. And we want to find the average rate of change from t equals 1 second, the t is measured in seconds, to t equals 2 seconds. Okay, so let's just appeal to the formula here. So we'll have f of 2 minus f of 1 over 2 minus 1. Note that the units on the top are going to be feet and the units on the bottom are seconds. So this really is a velocity. It's an average velocity. Represent that with a v bar, average velocity. So what we're going to do is we're going to put 2 into the function. So we'll do 100 minus 16 times 2 squared. That's 2 put into the function here. And then we'll put in 1 into the function. So 100 minus 16, 1 squared. And then we'll divide by 2 minus 1, which is just 1. Okay, so 100 minus 16t squared is going to be, well, 16t squared is going to be 16 times 4, which is 64. And then we'll have 100 minus 16. Denominator is going to be 1. We can stop writing the denominator now. So this will be 36 minus 84, which is 48, negative 48. And again, the units are feet per second. Okay, so let's represent what we just did graphically. So let's draw a graph of what we just did. So we have this 100, and let's say we're looking at this quadratic. So this quadratic outputs 100 at 0. If you put 0 into this function, you get 100. If you put in 1, you get 84. And if you put in 2, you get 36. So it's this quadratic function right here. And what we just computed was the slope between these 2 points. That's the slope here. The rise was 48. Well, it's negative 48 because it's going down. And the run was 1. So the slope of this line, the secant line, is negative 48. Okay, so now what we're going to do is we're going to consider this function 100 minus 16t squared, and we're going to find the average rate of change over some smaller intervals. So in particular, we're going to ask the question, what happens as we move B closer to A? Okay, so let's do 2 more calculations. Let's go look at t from 1 to t equals 1.5, and then t equals 1 to t equals 1.1. Okay, and you'll recall we had as a first part, like a 0 step, was t equals 1 to t equals 2. We already did this. So now we're doing, we're moving the 2, the right endpoint, B, even closer to 1. So it's moving from 2 to 1.5 to 1.1, and we're seeing what happens. Okay, so first let's compute the average velocity from t equals 1 to t equals 1.5. So the top will be f of 1.5 minus f of 1, and the bottom will be 1.5 minus 1. If we put 1.5 into the function, we'll get 64. If we put 1 into the function, that's still 84. The denominator is 0.5. If we take that difference, we'll get negative 20 over 0.5, which is negative 40, and again, the units are feet per second. Let's do it again for 1.1 and 1. So this time, if we put 1.1 into the function, we'll get 80.64. You can use a calculator to check this. If we put 1 into the function, we'll get 84. Denominator is going to be 0.1 now. This difference in the numerator is going to be 3.36. We're dividing by 0.1. Don't forget the negative sign. And that's going to work out to be negative 33.6 feet per second. Okay, so we're noticing a trend here. We have B, when it's 2, the average velocity is negative 48. When it was 1.5, it was negative 40. When it's 1.1, it's negative 33.6. And the question is, as B gets closer to 1, what is this average velocity, this average rate of change going to? And that's something we'll see in a future video.